So we're gonna be talking about a lot of different polynomial scenarios here. Don't worry about like the name, date, class. That's just standard on these documents. You don't need to do that for me. If you want to write your name, go ahead. But I don't make you do any of that. Okay, so the first thing to note. You with me? Just make sure. Okay. Apparently there's been a lot of sophomores that have been having tech issues. Have you heard that? I don't know what the deal is. Something's not working well with the sophomores. Okay. Are we good now? We can go? Let's do it. So, first thing you need to know is what is a polynomial? What do you see in the word polynomial? What do you see? Poly. Do you know what poly means? Multiple, many, poly, okay? So a polynomial is an expression with one or more terms. Did you say your notability is updating? Just cancel it. If you hold it down and then just cancel the download, it'll cancel it. Okay? An expression with one or more terms. So poly is a little deceiving there in that you can just have one term and it is a polynomial. But oftentimes you'll have more than one term and you'll see that as we go. I'm going to give you like 4 or 5 examples of different polynomials. Okay? The first one, I'm just going to change color each time so you know that I'm onto a different polynomial. Hold it down and cancel the download. Hold down the icon. Okay, so the first example is just a number. The number 5 is technically a polynomial. It is one term. It's the number 5. Okay. Another example of a polynomial would be a negative 6x. It's one term. It's a negative 6x. That is a polynomial. Another example of a polynomial would be 4x squared minus 1. So 2 terms now that we're subtracting. You can have variables with exponents. You can have variables without exponents. You can have no variable at all, and it's still considered a polynomial. And then I'll give you one more. 9x cubed plus 2x squared plus 4x minus 5. Okay, that is also a polynomial. Yes?
What's an example of a non-polynomial? What's an example of not that?
The square root of anything that doesn't square root nicely is not technically going to be the polynomial form. Most things in math could be considered a polynomial. It's just more what we're going to do with a polynomial that will come into play here. So understanding that it's multiple terms or it's one term. A term is like this is one term, right? This is 2 terms. This is 1, 2, 3, 4 terms. What are you doing right now? Put it away. So that's a polynomial, okay? Standard form, there are 2 components that have to happen for this to be in standard form, and I always want it in standard form. Just keep that in mind. The 2 things, the first one is it should be in alphabetical order. Okay, if it is in standard form, it is in alphabetical order. So if you have a C and a G and a P in your problem, the C's come first, and then the G's, and then the P's. Okay? The second thing is you want your highest exponent or exponents first. Okay, so alphabetical order and the highest exponents first. So here's a couple examples of this. And we may not do all of these, but there's some if you want to try some on your own too that we can. So if I want to put these polynomials into standard form, look at this first one. I have 3x plus 1 plus 2x squared. Which one of those do you think should go first? The 2x squared. You want your highest exponent first. So you're going to put the 2x squared. Notice that's a positive number. That sign in front of it stays with it. Okay, keep that sign in front of it. So if it's positive, we don't have to put a plus there. It's just positive. Okay. What will come next? The 3x. So that's a positive 3x. So it'll be plus 3x. And then the last thing is plus 1. So this is the standard form of that trinomial as it started. I'll explain trinomial in a little bit. Okay. Take a look at number 2. What should come first? 7k cubed is your first one. And it might be helpful to some of you to like slash things out as you go so that you don't reuse them or you don't mix up if you've used them or not. So if you want to cross them out as you go, like, hey, I used that one already, moving on, you can totally do that. What comes next? K squared. How do you write that? Plus k squared, okay? Plus k squared. It's a positive, so we're going to add it. If you want to cross it out, go ahead. What comes next? Had minus k. So minus k and negative k are really the same thing. That there's no difference there. So make sure that negative sign in front or that subtraction sign in front comes with you. You with me right now, Shane? Because you have not looked up here once to write down what I'm writing down. What comes next? Plus 64. Good. Okay, you try 3 and 4. See if you can put those into standard form. Feel free to talk to your neighbor about it or do it on your own. But see if you can get that into standard form. Highest exponent first. Sorry. So you want to do 3 first, so 2, right? You want to decrease in order. So 3, 2, so that's going to be 4, 7, 10, and we'll get there. Okay, tell me what you got for 3. Minus W plus 28. Okay, so that should be your standard form on number 3. What'd you do for number 4? Yes. Okay, so honestly, you guys, the biggest place I see mistakes is that negative out in front of a number needs to stay with whatever it is with. So a negative n cubed plus n plus 24. If there's nothing out in front of it, it's a plus. Okay?
I have a question.
Yeah.
How come we don't put the x together?
Because it's x to the third power and it's n to the third power and n to the first power. You cannot add those together. You could multiply those, right? That's what we've been doing so far. We've been doing like n to the third times n to the first, and then you can call that n to the fourth. But now we're adding them. They're not like terms. And if things aren't like terms, you cannot add them together. It's like saying n to the third is apples and n is oranges. So -1 apple plus 1 orange doesn't equal
What if it's like
anything.
If they have the same exponent, then you can have it?
If they had the same exponent, you could add their coefficients together. Yeah. Which we'll get to eventually. Okay. Number 5 and 6 get a little bit trickier because there's multiple variables, but there's also multiple exponents. So I just want to explain to you the best practice with that. We said it needs to go in alphabetical order. So you're going to start with A, and the A that's by itself, that's going to go first. Okay? This one is just remembering the process. There's A and B together. We want to finish out our A's and then end on our B's. So what do you think comes next? Right, this one that has the A squared and the B squared, because our A squared is what should be coming next for us. So this is plus 5A squared B squared. So then those two are gone. What do you think comes next? The 2AB plus 2AB. And then we'll have our negative 2B cubed, okay? So that's a little bit tricky because you feel like that B cubed should come before the B squared and the B. But really what happens is you finish out your A with whatever's there, and then you can move on to your B. Does that make sense? You want to try number 6 and see if you've got it? Do 6. What do you think is your very last term? 13. Good. So you're going to start with a negative C cubed. That one's gone. What's next?
Negative 7C cubed.
Yeah, negative 7C squared D squared. Then the 5D cubed, and then the 13. Okay.
I thought we had to do it alphabetical. So I put the...
So you want to do the C's first, and you want to finish your C's, and then move on to the D's. So the only D we had left was the D cubed, and then the one that has nothing. Okay? Okay. This is really a matter of just memorizing some information because you're going to be naming things for me, and you need to understand what different terminology means. So I'm going to give you an example of each one of these right next to the name of it, and then it's just going to take some time to make sure you understand what is what. If something has well, first of all, the degree is the, how do we want to say this? It will be, your degree will be your highest exponent. Let's just start there. Let's just think highest exponent for now. Okay, we'll get more into that as we go. So, for instance, if something has a degree of 0, if I said like x to the 0 power, what does that become? The number 1. So really when something has a degree of 0, there is no variable in it. It's just going to be a number because you could multiply that by something else. We call that a constant. It's not going to change. So an example of a constant would be just the number 7 is a constant. It has a degree of 0. It's x to the 0 times 7 would be 7. So that's a constant if it has a degree of 0. If it has a degree of 1, so if something was like x to the first minus 3, for instance, okay, that's a first power, x to the first minus 3. I'll show you an example over here. We'll put it here, x minus 4. Can you tell me if you graphed that, what it would look like? Y equals x minus 4. What does the graph of y equals x minus 4 look like? You would go down 4, and your slope would be 1. Up 1 over 1, up 1 over 1, up 1 over 1. What do you get? A line, a straight line, okay? So a degree of 1 is called linear. If something has a degree of 1, x to the first power, essentially, that's a degree of 1, it is linear, okay? If something has a degree of 2, it's called a quadratic. So if it's like x squared minus 3, that would be considered a quadratic because its highest exponent is 2. Okay? Something to the third power, so say we have 8x cubed, is called a cubic. We've cubed it, it is a cubic. And then the last one, let's say we have 6x to the fourth plus 2x, okay? Your highest degree is that 4. Any guesses?
Quadruplet.
What?
Quadruplet.
Quadruplet, that's a good guess. It's a quartic. Okay, so you go constant, linear, quadratic, cubic, and quartic. That's when you classify it by its degree, by the exponent that is the highest, okay? But you can also classify it by how many terms it has. So if it has 1 term or 2 terms or 3 terms or 4 terms, and these ones you've maybe heard, maybe all of them. I don't know, you'll have to tell me. If something has 1 term, so if it's like 6x squared, that's 1 term. Now, if it was 6x squared plus 2, that's 2 terms. Okay, when you add or subtract to it, that's another term. Anyone know what 1 term is called? Do you know what the prefix for 1 often is? Mono. This is a monomial. Okay, so if it has 1 term, it's a monomial. Okay, think along those lines. If it has 2 terms, x plus 4 has 2 terms. What's the prefix for 2? 2 wheels on a... That's funny, you both said bus. What kind of vehicle, what kind of mode of transportation has 2? A bicycle, right? By 2. So this is a binomial. Okay, 2 terms is a binomial. Okay, follow that pattern. Mono, bi, what's 3? Tri. A trinomial would be 3 terms. So that's like x squared plus 4x minus 1 is a trinomial. 3 separate terms. Okay, anything more than 3 is just called a polynomial. Now, technically, any of them are polynomials, but they don't name them specifically beyond 3. So polynomial is anything with 4 or more terms. Okay? All right, so we're going to classify these. I'm going to give you 3 minutes right now to work with your neighbor and see if you can classify each one of these. You'll, excuse me, you'll have one name from the left column, the degrees, and you'll have one name from the right column, the number of terms. So for instance, if I had, well, let's just do number 1 together so that you're clear on what I'm talking about. Number 1 is the number 6. What is that from the left column by degree? It is a constant and it is 1 term, so it's a monomial. Okay, a constant monomial. So you're doing that for the rest of the 5 that are there. Go. No, this is easy. This is fine. Listen, we're not doing all of it. We're not doing all of this. Don't stress. We're not doing all of it. My bad. You're going to add and subtract. I got sidetracked. So when you add and subtract polynomials, this is very straightforward, very basic. You've got this. You have learned in math that you're only allowed to add like terms, right? So if you have an x squared and you have an x, are you allowed to add those together? No, those are not like terms. They have to have the same variable to the same power. Okay? Sorry, didn't mean to throw you off. So take a look at this addition example here. You have a negative x squared plus 2x squared. What is negative x squared plus 2x squared? Not 2. It's like saying negative 1 apples plus 2 apples. Can't have negative apples, but your x squared is going to stay put. What's negative 1 plus 2? Just x squared. It is 1x squared. If you put the 1 there, I don't care. You don't need the 1 there. Okay? Move on to the next one. You have an 11x and you have a negative 5x and you are adding them. Okay? And this is how I always do these. I do 1 underline for one, and then I do 2 underlines for the next one, and then I do 3 underlines for the next one. I'll change colors too. But this symbol stays with it the whole way through. You're adding them together. So 11x plus a negative 5x is what? This is what this simplified to. So you have 1x squared, okay? Then you have a positive 6x, okay? Now look at your last one. 13 plus negative 23. What is 13 plus negative 23? A negative 10. That is your setup. Remember, you want to go in descending order for your exponents. So 2 to 1 to the constant. Okay? The ones that tend to cause more trouble are these ones, the subtraction ones. So if you checked out, check back in. Look at all of your exponents right now. We're subtracting. We're going to start with which exponent? X to the second. You want the highest one. So you're going to go 4x squared minus 3x squared. What is that? 1x squared. Okay? I'm not going to write the 1 in. You may if you want. Okay? So you're done with x squareds. Move on to x's. You have a 5x minus a 7x. What is 5x minus 7x? Negative 2x. So minus 2x. Okay? Here's where it goes hairy at times. There's nothing on this side that is a constant, that doesn't have a variable, but there is one here. And so it's really tempting to right now to say plus 1. Anyone see why that's wrong? This minus is going to all of these things. So this is minus 1. Okay? I'm going to do just a couple more of those with you, and then we're done. Okay, so look at this number 15. Okay, you have w cubed. Do you see another cubed?
Yeah.
You do?
No.
No other cubed. So that's just w cubed. There's nothing else there. Okay, move on to the next one. A negative 2w squared plus 3w squared. What's a negative 2 plus 3? 1. So that is 1w squared. Again, you don't have to write the 1 in. If you want to, go for it. Look at the last one. A negative 5 plus a negative 11. What is negative 5 plus negative 11? Negative 16. Okay? Is that Mrs. Branderhorst? She's fantastic, huh? I love her. Okay. I'm going to jump down to 19. Stop it. Okay. Number 19. This one's subtraction. So when you subtract, you have to make sure you subtract everything on that side. If you want to rewrite this, if you want to distribute that like a negative 1, you could rewrite the whole problem. I'm going to do this. You don't have to do this right now, okay? If you don't want to do this, don't do this. X squared plus 17x minus 3x squared minus 5x. Okay, you could rewrite it like that. If that's helpful to you, go for it. If you struggle with math, that's probably the simpler way to do this. If you're like, no, I don't need to do that, then don't do it. So you're going to go x squared minus 3x squared. What is that? A negative 2x squared. Okay. Then you're going to go 17x minus 5x. 17x minus 5x. What do you get? A positive 12x. That's your answer. Yes.
Are blurred problems gonna come in here?
Like these ones? I don't make you do those. Is that what you're asking about? No, they're gonna look just like this on your homework. Okay? That's the concept. Do you have any questions on that?